Hello dear students of grade 12. Welcome back for studying another lesson about one of the topics of physics book of grade 12. In this lesson, I'm going to be talking about the first physical quantity that's used to describe rotational motion or circular motion of an object. You know that in grade 11 you studied some physical quantities that were used to describe the linear motion of an object. Those quantities were displacement, velocity, and acceleration, force, and many more actually. In this, in grade 12 actually, in physics book of grade 12, we are going to use those quantities to describe the rotational motion of an object, but with a bit of modification actually. So we are going to use those physical quantities to describe how an object travels on a circular path, okay? So if I try to tell you what you studied in grade 11, physical quantities of grade 11, you studied three physical quantities: displacement, which was denoted by delta x, okay, and velocity or speed. You studied both of them, okay, which was denoted by v, okay, small v, and acceleration, which was denoted by small a, okay? In this lesson, I am going to talk about displacement because displacement is going to be the first physical quantity used to describe, circular motion or rotational motion. So first, let me remind you what displacement was in grade 11, okay? So let's define displacement. Displacement is the change in the position of an object, okay, on a linear path. Okay, is the change in the displacement of an object on a linear path. If I give you an example, guys, imagine we have a car which is initially at this point, okay, and then travels to here, okay? The car travels to this point. So this is the initial position of the car, and this is the final position of the car. I'm going to mark the initial position of the car as xi, okay, as xi, and the final position as xf. Guys, in physics, to find the change in something, we usually subtract the final to the initial, okay, xf minus xi. If we consider that the first or the initial position was 0 meter because the car was initially at rest and didn't move at all, so xi is equal to 0 and xf is equal to 5 meters. So if I find the displacement of this car, it's equal to 5 meters, okay? So, but if you look at the direction of the motion, the car is traveling to east, okay? It's traveling to east. So here, if I talk about the change in the position of the car, I would say the car has traveled 5 meters to east, has changed its position 5 meters to east, okay? So from this example, we conclude that displacement is a vector quantity. What do we mean by vector quantity? When a vector is, or when a quantity is a vector quantity, it has both magnitude and direction, okay? It has both magnitude and direction. So you may ask, what's the magnitude in this example? Guys, the 5 meter is the magnitude. The magnitude is the number that tells you how much the car has changed its position. And the direction in this case is actually the east. Okay? East is the direction. Guys, in physics, we usually represent or express the direction of motion of things with positive or negative. So east and north are considered as positive directions, and west and south are considered as negative directions. Okay? So in this case, I could have said the car has traveled minus or negative 5 meters. Okay? Negative 5 meters to east. The car could have traveled, or I could have said that the car has traveled positive 5 meters to east, okay, or just positive 5 meters. If the car, were to travel west, I could have said that the car has traveled negative 5 meters to west, okay? So this was everything about displacement in grade 11. Now I am going to talk about the quantities that are used in grade 12. The quantities that we are going to use in grade 12. We have the same 3 physical quantities, but instead of displacement, we put a prefix, okay, to it, angular displacement. This is what makes the quantity a rotational quantity. If you have just displacement, this shows that this quantity is used to describe a linear path or a linear motion. But if you put angular prefix, it makes the quantity being used for rotational motion. Okay, angular displacement and angular speed, and also angular acceleration. Guys, in this lesson, I'm going to explain angular displacement for you. Okay, I'm going to explain angular displacement for you. Angular displacement, if I describe it for you, if I define it for you, is the angle through which an object revolves in a certain direction. This is the definition of angular displacement, and this definition, I think, came 3 times in the Wazari exams. So please try to memorize it. If not understanding it well, try to memorize it well. So let me explain what we mean by angular displacement. I am going to draw a circular path for you guys. This is a circular path. If I change the color to make it more interesting, here we have a car, guys. I'm going to draw a car for you. If you look at the car from above, this is what you see, guys. Okay? This is what you see. The car is initially at that point and then travels to here. And then the car travels to here. So we can say that this is the initial position of the car, okay? And then the car has traveled to here. Guys, as you saw that here, the initial position of the car is marked as xi. But if you remember, in the previous lesson, I told you that the amount of revolution of an object, the amount of rotation of an object is found by 3 ways, by 2 ways. One of them is angle, okay? So here, if I want to mark the initial position of the car, I would say theta I, okay? Here I said xi, but here we use theta I because angle is used to find the amount of revolution of an object. And you know that, guys, to find an angle in a radian, we have to have arc length, okay? So this is the initial arc length, okay? This car has traveled to here. So this is theta f, okay? And this is SF. As you see, there is a change in the angle. This means that there is a change in the position of the car. So I can write that this two will make delta theta, okay? And this two will make delta S. So we all know that this is the radius of the circular path. This is the radius of the circular path. So if I find delta theta is equal to delta S over R, okay? Delta S is the change in arc length traveled by the object, okay? And R is the radius, okay, of the circular path. So we know that delta S is measured by meter and radius is also measured by meter. So these two units get cancelled. We can say that delta theta doesn't have a unit. But you know that, guys, in physics, no quantity can be unitless. So we use this 3 unit for delta theta, degree and ref. But which one is primarily used for delta theta? This one, actually, because this is the SI unit to measure delta theta, okay? This is the SI unit to measure delta theta. Okay. Now, it's time to talk about this. We know that delta x is a vector quantity, okay? It has both magnitude and direction. These two quantities, delta theta and delta s, are vector quantities, okay? Vectors. So they have magnitude and direction. Okay? The magnitude can be any degrees measured in radian, guys. It can be any degrees. It could be 5. Here it's equal to pi over 2, okay? Or 90 degrees. Here it is equal to pi over 2 radian. But the direction, guys, can be counterclockwise, clockwise, or it can be clockwise, okay? Or this car has only 2 options, 2 directions to travel. One of them is in exactly the same way that the clock travels, okay, or revolves, and the other one is exactly the opposite way that the clock revolves. If the car traveled in the same way as the clock travels, it would be clockwise. This is 12 and 3, 6, 9. If a car traveled in a clockwise direction, it will revolve in exactly the same way that the clock revolves, okay? If the car traveled in opposite direction of a clock, it would be the opposite. It would be counterclockwise. So here the car travels in this way. Guys, if a car traveled counterclockwise, delta theta and delta s are positives, okay? Delta theta and delta s and delta theta are positives. If the car traveled clockwise, delta S and delta theta will be negatives. Okay? This is the way that we use positive and negative sign for the direction of motion of the car. Okay, I hope you guys enjoyed this lesson, and I hope you understood it well.